Now in this lecture, we are going to discuss about the Kruskal's algorithm to find out the minimal spanning tree. So Kruskal's algorithm to find the minimum cost spanning tree uses the greedy approach. This algorithm treats the graph as a forest and every node has as an individual tree. So in this algorithm, the graph is considered as a forest and each and every node is a individual tree. A tree connect to another only and only if it has the least cost among the all available option and does not violate MST property. It is used for finding the minimum spanning tree of a given graph. To apply Kruskal's algorithm, the given graph must be weighted, connected, and undirected. So let us take what is Kruskal's algorithm. So the first step, sort all the edges from low weight to the high weight. Take the edge with the lowest weight and use it to connect the vertices of graph. If adding an edge creates a cycle, then reject that edge and go for the next least weight edge. Keep adding edges until all the vertices are connected and a minimum spanning tree is obtained. So let us take one example. So we take the same example what we have taken for the Prim's algorithm. So we have to construct the minimum spanning tree MST for the given graph using Kruskal's algorithm. So now if you want to solve or if you want to find the minimum spanning tree using the Kruskal's algorithm, what is our step number one? We have to first take all the vertices. So now how many vertices we have? So 7 vertices. So we have to write down all the 7 vertices over here. Now, out of that vertices, let us just select which vertices or which edge has the minimum weight. So just look here, the 1 to 6 has the minimum weight. So we first join these two vertices. After that, the second minimum weight is 12. So we join these two vertices. Then third minimum weight is 14. So we join this 2 to 7. Then 16 is the next minimum weight. So we join 2 and 3. Now, after that, 18 is the minimum weight. But if we add 18 over here, this will create a loop. So now we cannot take 18. So what is the next minimum? After 18, 22 is the minimum weight. So we add 4 and 5. Again, then 24 is the minimum weight again. But if we take 24 here, again the loop will be created. So we won't take this one. We go to the next minimum weight, which is 25. So we consider 25 like this. So this is what it is, the minimal spawning tree. So let us again show the process. First, we have constructed the line, join the vertices 1 and 6. Then second one is the 3, 4. Third one, 2, 7. Fourth one, 2, 3. Fifth one, 5, 4. And sixth one is 6, 5. So this is what? This is the minimal spawning tree using the Kruskal's algorithm. Let us take one more example. What is the sum of the weights of all the edges? So as we have already obtained in the Prim's algorithm, so we are getting the same answer, which is 99. Now construct the minimum spawning. Let me take another example, which we have already taken in the Kruskal's algorithm. So construct the minimum spawning tree, MST, for the given graph using Kruskal's algorithm. So again, what we will do, we have to just first find what are the different vertices. So which edges, what is the minimum weight of the edge? So 7 and 6 has the minimum weight. So we have selected this one. Then second minimum edge is 2. So either we can also choose this one, 6 to 5 or 8 to 2. So we have already taken over here. Now, in the next part, 4 is minimum weight. Then again, this 4 is minimum weight. This one. Here, this one. Then this one. After that, 7 is minimum one. And then 8 is minimum. Next minimum. And finally, 9 is the minimum. So all the vertices are included and the minimum number of edges are included. So this is what? This is the minimal spawning tree by using Kruskal's algorithm. So definitely we will get the same weight as we have obtained 37 in the previous example. So now here we are also getting the weight of the minimum spawning tree is 37. Let me show some examples. It is only for your reference. One example. What is this minimal spawning tree? So minimum, this is 1, 1, 2, 3, 4, then 6, at the last 10. Similarly, the total weight of the edges is 26. Again, we are also able to get what is its answer. It is this. Weight is 17. Weight is 10. Same thing we are able to use. So all have the same type. Weight of this is also 99. So what is the difference between Prim's and Kruskal's algorithm? So Prim's and Kruskal's algorithm are the famous greedy algorithms. They are used for finding the minimum spawning tree of a given graph. Both methods are used to find out the minimal spawning tree. To apply these algorithms, the given graph must be weighted, connected, and undirected. If all the edge weights are distinct, then both the algorithm are guaranteed to find the same MST. If the weights are distinct, if they sum, then it may be different. Like that, this is what this we are getting minimal spawning trees this by using either Prim's algorithm or Kruskal's algorithm. We get the same answer because all the weights are different. If all the age weights are not distinct, then both the algorithms may not always produce the same MST. However, cost of both the MSTs would always be same in both the cases. So these are some home assignment that can be easily solved using the Kruskal's algorithm. And these are the some references